everyone, so in this video we're going to talk about the key characteristics of exponential graphs. It's the same important characteristics we've been talking about for other functions like domain and range, which is all the x values and all the y values. Increasing or decreasing, is it going up or coming down? The intercepts, where does it hit the x-axis, where does it hit the y-axis? The end behavior, so what's happening at the ends of the graph? And this one is the only new thing is, what's the equation of the asymptote? Since the asymptote is always a horizontal line, the equation's always going to be y equals, and then whatever that y value is. It's just going to be a number. It starts off at 0, so let's look at just 2 to the x real quick. The function 2 to the x, which is kind of like our parent graph we've been using. 2 to the x, I know, goes through the point 0, 1. It has an asymptote here at 0, and then it increases more and more rapidly. So its asymptote is at 0. This is the line y equals 0. Its domain is all real numbers. You could write this for all real numbers, or you could say negative infinity to infinity, because it goes left forever and right forever. It never stops. You could plug in 1,000,000 and you'd still get out an output. So its domain is all real numbers. The range, it goes up forever. So it goes to infinity, but it does not go down forever. It never is going to cross that asymptote. And so the range goes to 0, well, let's say it's 0 to infinity, but it never hits 0, so we're not going to include the 0. That's why we do a parenthesis, not a bracket. So the range is only from 0 up, not including 0. This particular graph is increasing because it's exponential growth, because it's going up. Its intercepts, it does not have an x-intercept because it doesn't hit the x-axis. But this one's y-intercept is at 0, 1. Or you could just say 1. The end behavior is what's happening at the ends of the graph. On this side of the graph, on the right side, it's going up. So the way we'll write that is, as x approaches infinity, y approaches infinity. So as x increases, y increases. As x gets bigger, y gets bigger. So we write it like that. For the left side of the graph, as x approaches negative infinity, y is getting smaller, but it's not approaching negative infinity because it's not going down. It's kind of steadying out right there at 0. So it's approaching 0. That's why we say approaching, not like it's going to be 0. So it's approaching the value 0 because it's not going up and it's not going down. It's kind of steadying out right there at 0. So it's always going to match up with the asymptote. If the asymptote is 0, the end is going to be approaching 0. Let's try one example here. Instead of that parent graph, let's do this function. You could graph it in your calculator or on Desmos, but we could also graph this by hand. I know that this graph has been shifted left 1 and up 1. So rather than going through the point 0, 1, let's go left 1, up 1. Also, the asymptote, which was at 0, has now been bumped up 1. So it's here. So here's my asymptote now. And it got flipped upside down, so it actually gets moved down here. And it looks like something like this. All right. So first of all, is this graph increasing or decreasing? It's going down as we look at the graph from left to right. It's going down, so it's decreasing. Its intercepts. The x-intercept is right there at negative 1. So negative 1, 0 is the x-intercept. The y-intercept, I'm not exactly sure how accurate my graph is here. So if you want to find the y-intercept, you plug in 0 for x. So negative 2 to the 0 plus 1 power plus 1, which this is just 1. Negative 2 to the first power is negative 2 plus 1, which is -1. So my graph was pretty accurate. It does go through -1. So the y-intercept is 0, -1. All right, next, the domain. The domain for any exponential graph, unless it stops, is going to be all real numbers or -infinity to infinity, because it keeps going left forever and it keeps going right forever. It goes forever both left and right. But the range is not. The range, as we look at the y values, it does go down forever, but it doesn't go up forever. It stops at that asymptote and never goes past it. So the range is -infinity to 1, which is where the asymptote is. If you put 1 to -infinity, that's not wrong. It's just typically we put the smaller number first. The asymptote is also right there at 1. So it's the equation y equals 1. It's the horizontal line where y is 1. And the end behavior is as x approaches infinity, y approaches, let's look, as x gets bigger, the graph's going down, so y approaches -infinity, y decreases. And as we look at the other end of the graph, so as x gets smaller, as x approaches -infinity, it's going up, but it's not going up to infinity. It's steadying out right there at the asymptote of 1. So y is approaching the value 1. Again, like I said, you're going to notice that like the range and the asymptote and the end behavior, they all kind of hit right there at the asymptote, basically. All right, and that is it for this video.